Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called the Diamond Sea by Tallcat. And here are the rules. We have chaos construction rules, which means place the digits 1 through 9 once each in every row, column, and region. And we don't have the regions yet because they must be constructed, hence the name chaos construction. Regions are orthogonally connected and must be located by the solver. So by orthogonally connected, that means all the cells in a region must be able to connect to any other cell in the region by going through edges, and it should be able to stay within the region. So this is an example of an orthogonally connected region. This, however, is not, because if you try to go from this cell to any other cell in the region, you cannot just stay in this region just by going through edges. You have to go through a corner. Similarly, this doesn't work either, because to get to any of these cells, to any of these other 7 cells, you cannot stay in the region just by going through edges. You would have to go through a corner to stay within the region. And that's chaos construction rules. We also have XY differences, where each diamond between a pair of cells indicates that they belong to different regions. So this must be a different region than this. This must be a different region than that. This must be a different region than that, etc., etc. These two are in different regions also. So every diamond indicates that the cells that they're in between must be from different regions. And that the difference between the digits in them equals either the leftmost digit in the same row or the topmost digit in the same column as the pair. Oh, that's interesting. So basically, it's saying that these are in different regions, and the difference between these two digits must be the leftmost digit in that row, because they're in the same row. Or in this diamond says that these two digits difference must be the topmost digit in that column, because they're in the same column. That's actually very interesting there. And all possible diamonds are given. That is, where there is no diamond, either the cell belongs to the same region or the digits have the wrong difference, or both. So there is a negative constraint involved here. So basically, if these two digits were in different regions, they could not have a difference that would be the leftmost digit in this row. So that's very interesting, actually. Or if they have a difference in that is the same as the leftmost digit in the same. So say these two had a difference that was. So say this was like a 4 and this was 3 and 7. That would mean, because there's no diamond in between them, they have to be from the same region, because the difference between these cells is 4. But because they don't have a diamond between them, they cannot be from different regions. They have to be from the same region then. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so one thing that I figured out is the difference between these two digits is the topmost cell in the column. Well, what is the topmost cell in the column? It has to be this digit. So since the difference between these two digits is this digit, this must be double of what that digit is. So this is 1 through 4, and this must be 2, 4, 6, or 8. Same with this. This is the same problem, right? These two digits, the difference between these two digits is the leftmost digit in the row. So this must be essentially double of this. So this is 1 through 4. This is 2, 4, 6, 8. Do we have anything else? Yes, these. 1 through 4, 2, 4, 6, 8. 1 through 4, 2, 4, 6, 8. We don't have anything else in the topmost. Here, so if there are three differences here, what does that tell us? If there are three differences in a row, that means you have three differences that are at least three, I think, right? This difference, oh, that's interesting. This difference must be at most three. So this is 1, 2, or 3 here. Therefore, we have a 1, 2, 3, 4 quadruplet in column 1, which, okay, and let's also mark boundaries right now. So obviously the entire edge forms a boundary. These are boundaries. These are boundaries. This is a boundary. This is a boundary. These are boundaries. This is a boundary. Boundary here, here, and here. Boundary here, boundary here. Boundary here, here, and here. So this must be the same region, because otherwise this can't go anywhere. So this must go that way. This is then a different region than this. This must go somewhere, so it has to go to here. This then has to be part of that region because it doesn't have any other region to be part of. So this must be a different region than this, must be a different region than this. This is 1, 2, 3, 4, 5, 6 regions. So that's in that region, so this is 7. We have 2 more here, and we don't know where they are. So this difference is 1 through 3. This must be then 1 through 7 here. Right? Because this is a difference of at most 3. Because this difference has to be at most 3. We have 5 through 9 here. This has to be 5, 6, or 7. So this cannot be 1, because if this were 1, this difference would not be 3 or greater, because you can't have, the rest of the column 1 is 5 through 9. Therefore, this can't be 2 here. This difference is either 5, 8, 6, 7, or... Okay, well, we just know it can't be 9 here. So this difference is either 5, 6, 7, or 8. And we have 3 differences that make that. If it were a difference of 8, this would be... You could only have 1 and 9 here as a difference, and you can't have that. So this can't be 8. Can it be 7? No, that just gives you 1, 8, and that's it. 6 would also give you only 1... It'd be 1, 6, 2, 7. I guess it could be 1... No. 1, 7, 2, 8 as possibilities. So this can't be 6. This has to be a 5. Which means this difference is 5, 6, 7, 8. This can't be 5. So this can no longer be 2, because this difference, again, is only 3 at most. If this were 3 and 6, that doesn't work. This has to then be... This can't be 3 and 7. This has to be a 4 here. So this is 4. This is 8. That leaves this as not 4. This can no longer be a difference of 3. Therefore, this must be a difference of 2, right? Because these differences have to be at most 2. So it's not 3. Therefore, 3 is the other one. This can no longer be 5, though, so this must be a 6. So this is 6. This is the difference of 2, so this must be 7. This has to be 1 and 3. So this cannot be 4 and 8. This has to be a 2, 6 pair next to this 1, 3. So this can't be 4, 8. This is 2 or 6. There's a difference of 4 between them, so that's only 2 or 6 here. Then this can't be 2. It cannot be 4 because of the 2, 4 in the box. This actually works here, then. This is a difference of 2. So this also has to be 1 or 3 here. This is a difference of 4, 2, and 6. We don't know what this is. Okay, so this is 2 and 6. The rest of row 2. So the rest of column 1 is 8 or 9, right? This has to be its own region. And if it's different than this, it would have to go essentially out here, and that would block this from being a region. So this must be the same region. We're going to make that green. It has to connect. It has to get out. It cannot be here. It must be a different region than this. This is a different region than that, so this must go out here. This is a different region, though. And this region, where is this going to be? This must be the same region. Actually, let's make this pink. And we're going to make this green. This has to be green and go out there. This is a separate region, so it must go out to here. This pink has to go out here because there's no other place for it. This is a separate region. It's probably light gray. This green has to go out then. It has to go out again. 2, 3, 4, 5, 6. This cannot go. This is a separate region also. So this must go out to here at least. 1, 2, 3, 4, 5, 6, 7, 8. We have a ninth. It's either here or here. This is 1, 2, 3, 4, 5, 6, 7. This is a separate region. It needs to go somewhere. So we're going to make that dark, I guess. And then this light has to go somewhere. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the full region here. Which means the pink goes out here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is the last one, and then green has to go out here. And that's the last one there, right? 1, 2... Actually, is it? 1, 2, 3, 4, 5, 6, 7, 8. No, it's not the full. So this is green, and the green goes to either here or here. This is dark gray. Actually, not dark. We should have it make it medium. This is medium. I guess we'll make this dark then. We're going to mark this as red. It has to get out somewhere, so it has to go here. This must be a separate region. We're going to make that yellow. It cannot be green. This has to go out somewhere. It cannot go this way because that would block the red, so it has to go out this way. So this is yellow. It's only one of these. I guess it cannot go down here and block, so red has to get out too. So this is red. One of these is red, one of these is yellow. We're not sure which is which, because otherwise this also needs to continue out, and it can only be part of this. So this has to go out here. Only one of these can be each of those. So it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and then 7, right? So this is 8 total right now. Technically, this could be yellow, and this could be something else. So this cannot go this way. Green has to go the other way then, because this yellow region otherwise can't work. So this is done. This gray has to be able to go somewhere else, so it must go out here. This medium gray. This is a separate region. Here. The red can go to either here, so this can be red, yellow, this could be a different region, blue. This is 1, 2, 3. Well, you know, this is 1 each here. You have a difference of 5 between all of these. This has to be medium gray, because there's no other force for that. The rest of row 1 has to be 4, 6, 7, 8, 9. And this can't be 9. This can't be 4, so this is 6, 7, 8, 9, but this can't be 8 either. So 4 has to be one of these 3. This can't be 6 because of the 2, 6 pair in the column. These have a difference of 5, so it's either 1, 6, 2, 7, or 3, 8. So this is 1, 6, 2, 7, or 3, 8. Right? Therefore, that leaves 4 here. This cannot be 6 or 8. Cannot be 6 or 8. So this, if this is not 6, this can't be 1. Also, this can't be 2 because of the 2 in the region. This can't be 2 because of 2 in the region. So we remove 6 and 8. This means that can't be 8 and 3. This is 6, 7, or 8 then. It's with 1, 2, or 3. This can't be 2, so this can't be 7 here. This 2, 6 pair sees this 2, 6, this cell here. So this can't be 2 or 6, which the 6 eliminates 1 here. The 2 eliminates 7 here. Let's see. What other differences do we have? None of these can be 7, so we know 7 is one of those 3 there. 4 cannot be here because this is 4. This is a difference of 1 or 3, but we're not sure which. This difference has to be... obviously, you cannot have a difference of 9 here. Oh, yeah, where is the 9 possible? 9 can never have a difference, have the diamond be on that difference in that column. So this can't be 9. This has to be 8. So this is 8. This has to be 9. This difference then has to be a 1, 9 pair. Similarly, this doesn't have a difference, and I think every other one does, right? This does. This does. Oh, this one doesn't either, so this could be 9 also. So this cannot be 9 here, and obviously that can't be 9. This is a 1, 9 pair. This has a difference of 6, 7, or 8. This has a difference of 8. This is a difference of 4. So it's either 1, 5. It cannot be 2, 6. It could be 3, 7, or 5, 9. This has a difference of 4, 6, or 8. The different digits in row 1, sorry, row 2 have to be 1, 3, 5, 7, 9. And obviously this can't be 5, 1, 3, 5, 7, 9. So 5 has to be one of these 2 digits here because it cannot be here. This 2 means there's a difference of 4 and 6, 5 and 7, 1 and 3. That works. This has a difference of 7 or 9 here, and there's no differences in that column, so that's fine. This is 6, 7, or 8, which means this has to be up to 1, 7, 2, 8, or 3, 9, but this can't be 7 or 8. It cannot be 1 or 9 here. So this is... That's actually interesting. This is 2 or 3. If this is 2, this would have to be 8 or 9. If it's 3, it has to be... it has to be 9. If this is not 2, 3, that means this is a low digit. And the difference here is at least 6. So it would be 1, 2, 3, 7, 8, 9 that way. Obviously, it cannot be 9, cannot be 8, can't be 7 either. This then has to be 2 or 3, so this is with 8 or 9 here. And therefore, this difference can never be 8. It's 6, 7, which means 8 has to be one of these 3 digits here. And 8 cannot be here because 9 cannot be here, and you can't have a 1, 9 pair here. So this can't be 8. This has a difference, and this cannot be 1, 9. Because if this were 1, 9, these would have to be a 1, 9 pair, which would eliminate 1, 9 here. So this cannot be a difference of 8. which means this has to be the difference of 8, because that's the only place where it can be. Since this is 8, this can no longer, the only place for 9 has to be here. So this is 8, this is 9. This is 5. This 9 eliminates 9 in the rest of that region. Also, this can't be 2 because of the 2, 6 pair in the column. Since this can't be 2, this can't be 7. This becomes a 1, 3, 6, 8 quadruplet, which eliminates 1, 3, 6, 8 in the rest of the row. So this must be a 2, 7 pair here. And the reasoning we had that was this can't be 2, 6, or 8. Since this can't be it can't be 2 here, so this can't be 7 then. And this can't be 2 because of the 2 in the region, so that can't be 7. This can't be 2 in the region, so this can't be 7. And this sees both 2 and 6 in this cell, so it can't be 2, which means this can't be 7. So this is the 2, 7 pair here. This is a 1, 9 pair here. This is a difference of 1 or 3, 1 or 3. The rest of this row cannot have 9. Therefore, one of these two must be a 9, because 9 cannot be here. That eliminates 9 here. This yellow region cannot contain 2 or 6. So we have 1, 3, 4, 5, 7, 8, 9. Okay, what does that mean? I'm not sure. This can't be 5 or 9 because of the 9 having to be one of these two and the 5 being here. 2 could be here. We know 7's one of those two. This is a separate region. The rest of the pink region is 1, 2, 3, 4, 7, 9. So, okay, where can 7 be in the pink region? Cannot be here. It must be here. So this is 7. The rest of this is 1, 2, 3, 5, 9. So this can't be 9. Not 5, 9. 1, 2, 3, 4, 9. So this could be 4. This can't be 2 because of the 2, 6 pair in the column. Therefore, 9 has to be one of these 3 digits, which means that 9 cannot be here. This must be a 9 then. So this is 9, this is 1, which eliminates 1 here. This is 9. 1 cannot be any of these cells, so 1 is either here or here. We're not sure which. This cannot be 2, 4, or 9. Cannot be 5 either. So what digits can this be? It can't be 2, 4, 9, 5, or 7, or 8. So it could be 1, 3. No 2, 4, 5. It could be 6. So those are the only possibilities there. That means these digits, okay, in column 2, what are the remaining digits? It's 1, 3, 4, 5. But this can't be 1 because of the 1 in the row. This is also 1, 3, 4, 5. Remaining digits here have to be 1 through 6, but it can't be 1, so this is 2 through 6. This cannot be 2, 4, or 5, so it's 7 with 3 or 5 here. Can't be 5. 3 or 6 here. Okay. This difference is 8. That's fine. Okay. This cannot be a different region than dark. If it's a different region than dark, first it would be either medium or orange, which we designate. And if this is orange, then this dark has to go out, but it would block this medium gray region from having 9 digits. So this must be dark then. This is dark. Same problem. If this is orange, either of these are orange, that means the dark has to go out this way. The medium gets blocked then in that case, or the dark is blocked. So these both have to be dark. The dark could go out this way. We don't know. 1, 2. Okay, so this is 1, 2, 3, 4, 5, 6. It can only be one out of either out of 2 for either of these. So that would make 1, 2, 3, 4, 5, 6, at most 7, 8. So it has to go out. It could go out that way though. So it has to be one of these two then. 1, 2. It doesn't. This cannot be red. It could be yellow. I guess we'll make blue here as a possibility, and this could be orange. So it could go like that, right? 1, 2, 3, 4, 5, 6, 7. One of these is 8. Red could go here, or it could be blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the max here. 1, 2, 3, 4, 5, 6, 7, 8, and yellow could go extend to here. So this could be yellow. This could be orange. Technically, it could be blue here also. We don't know. Red cannot get to here. So this is blue or orange, essentially. But we're going to mark this as blue. Should we? I don't even know. This cannot be gray. Actually, how many? 1, 2, 3, 4, 5, 6. You have to have 7, 8, and 9. So this has to be medium gray no matter what, because there's no other way to get out. Therefore, this dark gray has to go this way, because there's no other. It gets blocked by the medium gray. Otherwise, if it tries to go this way. 1, 2, 3, 4, 5, 6, 7, 8. It could go here. 9. Can this ever be something not dark? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it could. But can these ever not be dark? It would be orange 1, 2, 3, but we would have 1, 2, 3, 4, 5, 6, 7 at most for the dark region. So this has to be dark. So this is dark. This is either medium or dark. This is either medium or dark. This is a difference of 2. Okay. These digits have to be 1, 3, 5, 6, 7, 8. It cannot be 6 or 7. Okay. Interesting. Okay. If this is 2 and 8, so the only way that this can be 2 and 8, okay. If we tried to make, if the only way this can be 8 is if this is 2, to have a difference of 6. So if this is 2 and 8, that would force this to be 6 and this to be 6, and that's not allowed. So this cannot be 8. This has to be a 9 here, which means 9 cannot be either of these two. This can't be 9. This difference is either 4, 6, or 7. So if it's 4, it could be 2, 6, 3, 5, or 5, 9. There's too many choices. The remaining digits in row 3 are 1, 2, 3, 4, 5, 8, 9. 4 and 8 cannot be here. 9 can't be here. And this difference has to be at least 4. 6 or 7. It could be 1, 5 for the 4. It cannot be 2, 6, but it could be a difference. Well, okay. What are the possibilities? Okay, this can't be 5 because of the 5 here. This can't be 9 either. Okay, so this is a difference of 4, 6, or 7 here. We have one. So this could be either dark, technically could be medium, or it's orange. We don't know. The dark could potentially go up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So the dark could go up to here. This is a different region, so this is orange or blue. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the medium can go up to here. That means this is essentially, we're going to mark this as orange. These could be orange though too. This could technically be blue. This cannot be medium gray though. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it could be medium gray. Okay, so that could be medium gray also. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, then this would be a 10 cell region. That's not possible. So this cannot be medium gray. This is orange. This has to be orange. Because this would then form a 10 cell region, which is not allowed. We have to have a 9 cell region in chaos construction. So the rest of this is orange or blue. Okay. This is 4. If this is, say this was 7, you have a difference of 4 or 6 here. So the difference of 4, oops, would be 3. So 3 could be here if this is 7. If this is 4, if it's 6, it could be 7 and 1. If this is 5, you can't have a 9 here. The 5 can only be next to 1 because you can never have a difference of 6 or greater for a, or 5 or greater for a 5. For 3, a difference of 4 would make this 7. A difference of 6 would make this 9, but that's not possible. So that works for 3. For 1, difference of 4 is 5. Difference of 6 is 7. Difference of 7 is 8. So this has to be 1, 3, 5, 7, 8. For this, it could be 2, 6, 3, 7. Cannot be 4, 8. Could be 5 and 9. For difference of 4. For difference of 6, that's 2, 8. And 3, 9. For difference of 7, it would be 2 and 9. And those are the only possibilities. Okay, so you, wait. But for a difference of 7, you would have to have 2, 9 here. But that 7 would eliminate 7 here, so this would be 2. So you couldn't have the 2, 9. So this can't have a difference of 7 then. It's only a difference of 4 and 6 here. Where is the 9 in row 2? Can't be here, can't be here anymore. Can't be here because of this 9. Can't be here, so the 9 must be one of these. And it has a difference with a 4 between these digits. So this must be a 5, 9 pair, which eliminates 5 and 9 in the rest of the column. So this can't be 5 anymore. This can't be 5. Where does that leave 5 in this light gray region? It has to be here. So this is a 5, which eliminates 5 in the rest of this row. Can't have a difference of 6, but we don't know what that is. Again, 7 could be next to 3, 7 could be next to 1, 3 could be next to 7, 1 could be next to 7 or 8. So if this is 8, this has to be 3. If this is 8, this is 3. If this is 6, this is 1. Okay, so 6 has to be one of these two cells, which means this can't be 6. This must be a 7, which eliminates 7 in the rest of the column, plus this difference has to be now 7, which makes this a 2. So these can't be 2s here. This can't be 7 anymore, so this can't be 1 and 8 here. So this has to be 3, 7 or 1, 7 here. To have a difference of 4 and 6. Therefore, 7 has to be one of these two digits, which means 7 cannot be here. Where is the 7 in row 6? It has to be here. So this is 7. This is a 5-9 pair. We have 1, 3, 7 here. This becomes a 1, 3 pair here, which eliminates 1 and 3 in the rest of the region. So this can't be 3, which means this can't be 8 here. This becomes a 1, 3 pair here also then. Oh, that's interesting. So this digit cannot be that one. It must be the same as this one. So we're going to mark that as an A. This is B. This must then be B. This has to be A, which makes this B. A cannot be either of these, and B sees all of these too. So this can't be 3 or 1 or 3 here because of the 1, 3 pair in the column. This can't be 1 or 3. This can't be 1 or 3 because it sees B and A, so A has to be one of these two. This can't be 2, though, because of the 2 in the column. 2 has to be one of these two. Okay. If this is 3 and this is 6, this would then have to be, okay, that works, 8 and 3. If this is 1 and 2, this would be 1, and then this would be 6. So I think 6 has to be one of these two digits here, right? If this is 3, this is 6, obviously. If this is 1, this is 2, but this is 1, and then this must be 6 to be a difference of 5. So 6 has to be one of these two, which means 6 cannot be in the remaining digits in column 4. These two have a difference of 5. This has a difference of 1, 3. Okay. If this is 3, it has to have a difference of 1. Right? Because this 3 would force us to be 1 and 2. So this difference of 3 would mean this can't be, cannot be 2, because this would be 1, 2. So it would have to be 3, 4 if this was 3. If this is 4, actually, yeah, we should have been able to figure that out. Anyways, we came up with the same logic here, but this had to be the same region because this difference has to be the same as if this is 1, 2, this is 3, 6. If this is 3, 6, this has to be 1, 2 because of the way that that works, right? So it would have had to be the same region anyways. But okay, so this can't be 1 or 3 because of the 1, 3 pair in the column. if this is 3 again, this is 1, 2, this has to be a difference of 1, so it's 4. 4 could be a difference of, if it's a difference of 1, it could be 3 or 5 here. If it's a difference of 3, that would force this to be 6. This could be 1 or 7, and that could work either. If this is 5, then this has to be a difference of, it could be a difference of 1. It cannot be 6 because this is a 2, 6 pair here. It cannot be, so if it's 5, it could have a difference of 1. It cannot be 6, it could be 4 already. If it's a difference of 3, it cannot be 2, it would have to be 8 here. But if there's a difference of 3 here, this would then be 6, which would eliminate 6 here, so this would be 8. So this is the possibilities here. These digits, now this is interesting. If this is 4, the difference of 1 would be 5, and that works. So this could be 5. If it's 4 and a difference of 3, this could be 7. That works. If it's 5, it could be a difference of 1, but it would have to specifically be 4. That could work. If it's 5 and a difference of 3, it could be 8. And that could work. 6. If this is 6, that forces this to be 2, which makes this 6, 3, which makes this 1. So this has to be a difference of 1. It would be 5 or 7. That also works. Okay. What does that mean here? Okay. One of these cannot be dark. Well, we already knew that. Obviously, one of them is dark. The other one, so the dark then already has a 9. So if it goes, well, this could be a different region. We don't know the difference between these two, though. One of those is a 6. The remaining digits in column 3 are 1, 3, 4, 6, and 8. Remaining digits in column 5 have to be 2, 4, 5, 6, 7, 8, and 9. Hmm. One, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 digits. So this cannot be blue. I think this has to be orange also then. Right? If we try to make this blue, how do you connect then to here? Well, technically this could actually be orange also. Yeah, so that's not actually a guarantee. Technically it could be part of this. If this were 1, that would mean this is 3. So if this were 1, this would have to be 3, which would force this to be 1. This is the same 1. This 1 would make this 3, which make that 8. But this would be then a difference of 7. And it would be cross borders, so this cannot be 1 here. It could technically be 3. Hmm. It can be any of these 3 technically. One of these is 7. So one of these is a difference of 1, and the other one's a difference of 3, but we're not sure which is which here. Rest of row. Okay, rest of rows 5. One of these has to be an 8. We also need a 5 here somewhere, but we don't know which one's which. And then the last one, so 9 has to be one of these. Oh, this has to be 2, and it also has to be 9. So this is a 2-9 pair here. And that's because 2 couldn't be here and 9 couldn't be here. 9 couldn't be here, 2 couldn't be here. That's why this is a 2-9 pair. Interesting. If this is 2, so one of these 2 digits is a 2, one of these 2 digits is a 2. That eliminates 2 from the rest of the column. And in fact, if this is 2, that forces this to be 6, which makes this 2, this 1, this 3, and that would be 1. So if this is 2, 6, so that difference of 3 is fine. If this is 2, this is 6 and 3, so this would not have a difference of 1 in that case. Okay, so that's fine. Oh, that's interesting. If this is 2, this becomes 6. Huh. If this is 2, this becomes 6. This is 2. This is 1. You have 3. Let's try this. If this is 9, that makes this 2. If this is 9, this is 2. This is 6. This is 8. This is 3. That seems okay. Okay, 4 through 9 here. These can't be 2 either. So we have 1, 3, 4, 5, 6, 7, 8. Okay, that's all of them. None of these can be 9 here. Remaining digits here. One of these is a 4. Therefore, this is 5, 8 with 1 or 3 as possible. 1, 3, or 6, actually. This can't be 1, though, because of the 1 here. We don't know if these go across borders. This red needs a 2. It could be here, technically. This cannot be 4. If this were 4, it would have a difference of 5 between with 9, and therefore this would have to be marked with a diamond. So this cannot be 4. Uh, can this be 6? That would mean none of these are 6. So this would be a 3, 4, 5 triplet, which would force this to be 1. This would be 1 and 2. This would be 1 and 3 then. If this is a 6, none of these can be 6. Why was I trying to make it 6? I don't remember. Okay, this is interesting. So, if this were a 6 here, that forces this to be 2, 6, 3, 1. So obviously this is 1. This becomes 8. This becomes 3. This is 6 and 1. That's fine. This becomes 9. This is 2. That's all kosher. This would be a 1, 3, 1, 3 pair, so it could not be 3. Therefore, this would be 1. This would be 3. This would be 1. This would be 2 and 6. So this would have to be 5 or 7. So this would be 4 or 5 here. Okay, that's interesting. So far, that looks okay, right? Um, yeah, that seems fine. Um, so one of these two is a 6. We know that for certain. But this 6 doesn't seem to do anything here. Okay. This light region's essentially taken care of. Pink is all taken care of. Green is pretty much taken care of. This medium gray needs a 5. And it cannot exit out anywhere else. So the 5 has to be one of these two. Right? It can go 1, 2, 3, 4, 5, 6, 7, 8. It cannot go down here. Can't go down here. Can't go here. Anyways, it needs access to a 5. The only way to access a 5 will be here, so it cannot go down here. Right, so this must be orange. Or technically blue. Therefore, the gray has to include one of these. So it's 1, 2, 3, 4, 5, 6, 7. We have an 8th. And this could be 9th, or this could be 9th. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This has to not be orange. So this cannot be orange either. So this is medium and gray. Sorry, medium and dark. The 5 has to be one of these two. So 1, 2, 3, 4, 5, 6, 7, 8. And then it could be either here or here. It cannot be here because these are different regions. So this actually must close off there. This then must be a different region. period. So this has to go out this way. This has to go out here. So this is orange here. We don't know where blue really is here. This is orange, orange. This could technically be blue. These... Okay. So this is a 4-6 pair for the darks. That eliminates 4 and 6 in the dark region, so this can't be 6. This has to be a 2 then, which makes this 6. That means this is 3 to be in a 1-2 ratio here. This must be 1. That forces this to be 3. This has to be 8. This is 6 and 1. This has to be 1. Okay, so that follows that. This can't be 3. This can't be 2 anymore because of the 2 in the column, so this is 9 and 2. That eliminates 9 here. This is a difference of 3. So this cannot be 3. This can't be 3. It's 4 with 1 or 7, and 5 cannot be 2 or 8, so this must be 4. So this is 4 with 1 or 7 for a difference of 3. This can't be 4. This can't be 4. 5 can be with 4 here. 6 can be with 5 or 7, so this can't be 8. This can't be 8 or 4 then. This can't be 2, 3, 6, 4, or 8. No, 3, 6, or 4, or 8. Okay, so this is 1 or 9, 4, or 8. This one means this can never be 1 here. This can't be 1. So this can't be 3 anymore here. This is 1 or 6. So A is one of these two. This can't be 1. So it's the 3, 4, 5 triplet. This can't be 1 or 6. That forces this to be 3, 4, or 8. If this were 3, it would have to have a difference of 1, because that would be 1. And 3 would only be difference of 1 with 2 or 4, and that's not possible, so this cannot be 3. If this is 4... This is 1 or 7, difference of 3. This is a difference of 1, 5 with 4, 4, 6 with 5 or 7. So either one of these is 5 or 7. Okay, so this can't be 9 here. Why can't that be 9 again? I don't remember. Oh, because this is 9. Okay, there you go. There you go. If this were 1, well, it can be 1. 4, 6 pair. So where is the 9? Okay. This cannot be 9 because the yellow and the red both have a 9. So where is the 9 in column 4? It has to be here. So this is 9, which means none of these can be 9 here. There has to be a 9 in one of these two cells here because that's the only place now for the 9 for the blue region. The orange has its 9 already, so this has to be, one of these two has to be blue. And 9. This can't be 1 because of the 1 in the row. For for the medium gray region, we need a 7. And it cannot be any of these. Can't be here. So one of these two must be a 7, which eliminates 7 in the rest of the column. So this can't be 7 here. 3, 2, 4, that's fine. 4, 1, 7, that's fine. One of these is 5, that's fine. If this were 3, this could be 4 with 1 or 7. That would work. If this is 1, this could be 8, 7, or 4, 5. Okay. Okay. Technically, the orange could go to something like this, right? And then the blue cannot cut off there. Oh, that's actually a good point. So the orange, can this ever be blue? 1, 2, 3, 4, 5, 6, 7, 8. Oh, the orange could go to here. Oof. Okay. 3 cannot be in the gray region, so none of these can be gray. This can't be 1 either. Sorry, the medium gray region. So the dark gray region needs a 3 and a 7 remaining. So it could just be this, right? That seems fine. The medium gray region, I think I said this was dark gray. Anyways, the medium gray region needs 5, 1, 2, 4, 7, and 8. So 8's one of these 3. So this is 3 or this is 3. We're not sure which. If this is 3, that makes this 5. Yeah, this is not a difference of 9. This is fine. There's no difference there. 5 will not have a difference of 3 with 1 or 7. Okay, this cannot be 3. So this is 1 or 6 here. This can't be 8, obviously. 5 is one of these 3. 5 is one of these 2. Oh, that's interesting. If this is 5 and this is 4... Oh, they don't necessarily have to be part of that region. Okay, this... don't know which region that is. 4 can have a difference of 3 with 1 or 7. Can have a difference of 1 with 3 or 5. Can't be 5, though, because of the 5 in the column. 5 can have a difference of 3 with 2 or 8. Ugh, this is too broad. Even this is kind of broad, but... Where is 3? 3 has to be one of these 3 digits here. Cannot be here because of the 3, 7. This adds to, this has to be a difference with 4 of 9 and 5 then. This can't be 3 because of the 3, 4 pair. This can't be 3 because it's 1. So if 3 is one of these, it has to be 3, 7 or 3, 9. That doesn't really tell us much. Oh, this can't be 7 because of the 7 in the row. No, we should have been able to figure that out earlier. So this is 7. That means this has to be a 3, and it cannot be medium gray. Therefore, it's dark. Therefore, this cannot be dark here. This is medium gray. This cannot be 3 then. This is a 1, 2, 4, 8 quadruplet, which eliminates 1, 2, 4, 8 in the rest of the row. So this is 3. This is a difference of 4, which makes this 4, which makes that 6. This then has to either be 2, 8 or 3, 9. So this would be 9 and 3 or 2 and 8. This is 6. This is 1, 2, 4, 8. This is a boundary here. This cannot be 8 then because that would be a boundary and that would be a difference of 5. That eliminates 3 here. So 8's one of these two, which isn't helpful right now. We need a 7 for this medium gray region. So this is 7, this is 2, which eliminates 2 here. This cannot be 8 because then this would be a difference of 6. So this must be 4, which makes this 8. This can't be 4. This is a 1, 2 pair. Okay, so this cannot be 6 then. One of these is 8 or 9. Actually, we can't have a 2 here. So this 2 eliminates 2 here, so this must be 3 and 9, which eliminates 9 here, so it's 5 and 9. That 5 eliminates 5 here, so this is 8, which means this can't be 8 here. This is a 7-3 pair. This 3 eliminates 3 here, so this is 6, which makes this 5. That makes this 3, which makes this 1. This has to be 6, so this can't be 6 here. 5 can only be consecutive have a difference of 1 with 4 out of 4, 5, and 7. So 4 and 5 cannot be here. 8 can't be here. These have to be the same region because it's a difference of 1. So this cannot be yellow. This is red. So this is 1, 2, 3, 4, 5, 6, 7, 8 reds, and this must be the 9th. So neither of these can be red here. This has to be blue then. It cannot be orange. This gray cannot be medium gray because we already have a 9. So this is dark, which means this can't be dark. So we have those regions. This can't be a difference of 8, so this must be 2, which makes this 1. That 1 eliminates 1 here, so this is 8. That leaves just, what other digits remaining? 2 and 7? No, 2 and 4 in column 6. This 2 is not 1. Okay, this is 3. So this is 3. This is a 1, 2. This 1 eliminates 1 here, so this is not 7. This 3 eliminates 3. 2. This 2 eliminates 2 here, so this is 6. 3 eliminates 3 here. It's 4 and 3. This can't be 3 or 4, so this is 5. This can't be 3. These are a difference of 3 now. 2 can't be in a difference of 3 with 6 or 7, so this is 4, which makes this 7, which makes this 6, which makes this 2. This is a boundary. This can't be 7, this can't be 4, this must be 8, which makes this 5 to have a difference of 3. This yellow must have an 8, so this can't be yellow, this must be red, which means this can't be red, this is yellow. So this region's like this. Red is done. Yellow cannot be here because it's a 4, so this is blue, which makes this have to be blue. So this can't be 9 here. This is a region this way. The yellow needs access to a 1. It cannot get access to a 1 here. This must be 1. This is the only one, so that's yellow. This can't be yellow. So this region is that way. That remaining digit is a 7. This 8 eliminates 8 here, so this is 4. This can't be 5 or 7, so this is 1. The remaining digits in row 9 are 3 and 8. And this can't be 3 because of the 3 in the column. So this is 8, this is 3. Remaining digits in row 7 are 5 and 6. And this can't be 6 because of the 6 in the column. So this is 5, this is 6. These have to be different regions. This cannot be blue because we already have a 7 in this blue region. So this can't be blue. This is orange. That means this 5 eliminates 5 here. This is 1. This is 5. This cannot get access to here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it can get to there at most. So this is not blue. This is orange. Therefore, 1, 2, 3, 4, 5, 6, 7. We need access to a 1. Well, the only way it can access... Well, it could be here. So this is 1, 6 or 1, 6, 6, 1 this way. So these are the same regions. These cannot be orange. They're blue. This cannot be orange. It's blue. So this is 1. This is 2. And where are the regions here? This cannot be different borders because this is a difference of 1. So this must be blue, which makes this blue. Because this can't be blue anymore. This is orange. So these are the regions then. This must be 2, and this is 1. And that's how you solve it. Pretty cool, actually. It didn't seem that hard, but it was basically getting this last part solved. And it was basically finding... finding out this 7 and basically figuring out I needed to clear the 7 in that row. That was really the thing that was holding me back. Everything else was pretty straightforward, I felt. Relatively speaking. Chaos construction rules tend not to be very straightforward because they don't necessarily seem the most straightforward, but that's just because there's so many possibilities usually out there. And it's usually just not spotting those possibilities, right? If you can follow what the actual solve is, it's actually pretty straightforward. But sometimes you have to find that path, essentially. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.